So moles questions that specifically um so moles, just one second. Moles questions that specifically require a redox I mean that they're involved with redox reactions, they kind of tend to be slightly more difficult or confusing. I mean, they're not actually that difficult, but just it gets slightly confusing because of the whole balancing thing. Because balancing is slightly tougher. So I'm just going to quickly do one of them. Actually, I'm going to pick the first one, which is this one. Let me just copy paste that. Not this. So there was a typing error at the end. Right at the end, there was a typing error mistake. So let me correct that. So this at the end was not H2O, it was actually N2O. Okay, that was the mistake. I said let's try and do this very quickly. Okay, I'm just going to do one of them. Uh, Remember, the first thing is when you're trying to balance a redox equation, you have to figure out the oxidation states of all the elements. So phosphorus is a neutral element, so that's 0. You can figure out the oxidation state of N and O. O you already know, that's -2. N you have no idea, so that's taken as X. And there are two oxygens, so that's -2 times 2. And the individual charges, they must add up to be equal to -1. And if we solve for X, what do I get? I think it's going to be +3. So that means N over here is +3 and O over here has an oxidation state of -2. O and H, you already know that. O is -2, H is +1. H is +1, O is -2. Then over here, let's try and figure this out. I've got H, that's +1, I know that, and there are two of them. Then I've got P, which I don't know what P is. Then I've got oxygen, which is -2, and there are two of them, so that's -2 times 2, and I'm going to add all of them up, and it's a molecule that has an overall charge of -1. So this should add up to be equal to -1. Can anyone do math quickly and tell me what that is? I mean, is this coming out to be
1.
okay, so this is coming out to be 1. So that means P over here is +1, O is -2, and H is +1. And what about N2O? There are two N's. I don't know both of them, so that's X, 2X, and there would be one oxygens, and it's a neutral molecule, so it should be equal to 0. And if I solve this, X would come out to be equal to +1. So that means N is +1, O is -2. Okay, so is this clear to everyone, what we just did? Okay, Mariam, is this clear? Anna, Alicia, France, is this clear?
Yes.
Yes.
I said now the next,
Yes, sir.
okay. Now the next, I mean, you found the oxidation states, right? Now the next part is, I'm going to rub this off. Let's just remove this. Let's just take it to the side. So now what we have to do is we need to figure out who's the one gaining electrons, who's the one that's losing electrons. So look at P, what's happening to P. P goes from 0 to +1. So that means this is getting oxidized. It means it lost one electron. And over here, I'm talking about just a single P. Like, I'm not talking about the four P's combined. I mean, the P is not balanced at the moment. So I'm just talking about the oxidation state of a single atom of P, that it goes from 0 all the way to +1. So that means it lost one electron. And if you look at N over here, N goes from it's +3 and it goes all the way to +1. So that means it's getting reduced. And it gains 2 electrons, plus 3 to plus 1. So the charge is getting reduced. Now, one thing that so basically I need to balance the number of electrons lost and gained, which can be simply done by multiplying this by 2. And because if nitrogen is gaining 2 electrons, P should be losing 2 electrons. So I need to multiply this by 2, which means I need to have 2 P's. The problem is that I don't want to balance the equation in terms of fractions because I don't have 2 P's. I mean, even if I keep it 1, there are actually 4 P's. So what I'm going to do is just to avoid fractions. TK, listen to this carefully. Just to avoid fractions, I already have 4 P's. So what? How many electrons would be lost by 4 phosphoruses? Like I'm keeping this as 1 just to avoid fractions. So this was for 1 phosphorus. My equation has a total of 4 phosphoruses. If I keep this as 1, so that means the total electron lost are 4. So that indicates that the total electrons gained, they must be also 4. I need to multiply that by 2. So that means there should be 2 nitrogens. And there are 2 nitrogens already over here. So that's balanced. Now the number of electrons gained and lost are balanced without going into fractions. Okay, because the problem was that even if I keep this as 1, uh, I still have 4 phosphoruses. So each phosphorus is losing 1 electron. So in total, 4 phosphoruses would be losing a total of 4 electrons. And now the equation kind of looks all balanced. The only thing is this should be 4 because the p's are 4. I mean, there are 4 p's. So I need to multiply this by 4. Now the equation is balanced. And the only thing that's not balanced is going to be balanced the old-fashioned way by just balancing the number of atoms. So it's OH and H2O that needs to be balanced. Uh, you've already balanced the number of electrons lost and the number of electrons gained. Is this clear so far? Is this clear?
Yes.
So how, and even in this equation, balancing these two is also kind of tricky. I mean, you just have to balance the atoms, that's it. The electrons have already been balanced. So if you look at the total number of oxygens on the right side, that's 8, and there's 1 over here, so that's 9. So I'm going to write that over there. It's you've got 9 oxygens on the right side, right? I mean, oxygens. And how many hydrogens do you have on the right side? That's 8. So that's just 8. So on the left side, there should be 9 oxygens and 8 hydrogens. So all the hydrogens are over here. So I need to make this 8. I need to multiply them with a number. So the number of hydrogens become 8. So it's either going to be, I mean, what I can do is I can have 2 water molecules and I can have 4 OH ions. So that would make the number of hydrogens 8, right? Uh, but then how many oxygens do I have? That's 4. 4 over here as well. So that's 8. And there are 2 over here, that's 10. So that is not getting balanced. So think of another number. Let's think of, I need to make the hydrogens 8. So if I put 3 over here, that's 6 hydrogens. So there would be 2 hydrogens over here. So if I do this now, the hydrogens are balanced. That's 6 plus 2, that's 8. So the hydrogens are balanced. What about the oxygen? That's 4. Plus there are 2 over here, so that's 6. And there are 3 over here, that's 9. So I got 9 oxygens. So these two numbers would balance out the oxygens and hydrogens. So is this clear?
Yes.
TK, is this clear to everyone? France, is this clear? Mayim?
Yes, sir.
Okay, just so balancing redox reactions. We actually still have time, so I can actually do one more before moving to the moles questions. I mean, we have to. Let's quickly try. Let's very quickly try and do this one. Okay, I'm just going to. As the reason I'm actually spending time on this is because, especially in the theory section where you have a longer question on moles, sometimes what happens is that the initial equation is something like this, and they're asking you to balance it. If you don't have a balanced equation, you won't be able to actually solve the question correctly. And if the stoichiometry or the balancing is not right, I mean, you will struggle with the rest of the question. So this one, very quickly, I'm going to tell you the oxidation states. I is x, so unknown. Oxygen is -2, so that's times 3, and the total charge is equal to -1, so it's equal to -1. IO3 is -1. So you solve this, I comes out to be +5, and O comes out to be -2. N2O, we did that in the previous question as well. N was +1 and O was -2, and H is already +1. Iodine over here is neutral, so that's 0. O is -2, N is +2, and this is +1 and -2. So we found the oxidation states, who's losing and who's gaining electrons. So N goes from +1, N is getting oxidized, +1 to +2. That means it lost exactly 1 electron. And I, on the other hand, it's going from +5 all the way to 0. So +5 to 0, that means it's gaining 5 electrons. So reduction and oxidation. Now the simple thing that I can do is I need to multiply the first one with, I mean, there should be 1 iodine, and there should be 5 nitrogens, right? And the equation would be balanced. Again, I don't want to go into fractions because 1 iodine means I need to put half over here. So because of that, think of another number so that the two are balanced without putting a fraction over there. Because if I want to make it 1 iodine, this has to be half I2. So I don't want to balance it in terms of fraction. So I'm going to think of another number which would make the electrons gain and lost equal. That other number could be, I mean, initially it could be 10. I can make them 10 each. So I'm just doubling the number. So if you have 2 iodines, so I'm going to make this 2 iodines. So now I don't have to put a fraction over here. There are already 2 iodines on this side. So each iodine is gaining 5 electrons. 2 iodines would gain a total of 10 electrons. And similarly for nitrogen, it was losing 1 electron. Just to balance out the number of electrons, there should be 10 nitrogens. So this should be multiplied by 5. And this should be multiplied by 10. And now your equation looks balanced. I mean, the parts where the redox reaction is involved, they are now balanced. This is balanced. The electrons gained and lost are balanced. There should be 1 iodine and there should be 10 NO molecules. So is this clear up to this point?
Yes.
So I have a question.
Yes. Yes, Franz.
What if I multiply the nitrogen by 2?
You're talking, we didn't multiply the nitrogen by 2 anywhere. You're talking about the iodine?
No, sir. Why can't I multiply the nitrogen by 2 so I get 2 nitrogens on the products?
Just 1 second. 2 nitrogens in the products. Nee, listen, France again. Nitrogen, how many electrons? I mean, you don't have to multiply nitrogen. So you're talking about this one, NO, right? That why you shouldn't multiply.
Yes, sir.
Nee, the reason is you have to balance the number of electrons gained and lost. That's the reason. I mean, you can't balance it the normal way. How many electrons is nitrogen losing? It's losing 1 electron. Nitrogen is +1 over here, and nitrogen is +2 over here. So that means it lost a total of 1 electron, one of the nitrogens. Iodine, on the other hand, was going from +5 all the way to 0. So that means one of the iodines is gaining 5 electrons. So you need to multiply both numbers, both of the atoms by such a number that the number of electrons gained and lost, they become equal. So which is why I multiplied the iodine with 2. I had 2 iodines because now the number of electrons gained would be 10. And since each of the nitrogen was gaining just 1 electron or losing 1 electron, so I multiplied that by 10 so that the number of electrons gained and lost, they become equal. So instead of actually balancing the atoms, what you're trying to do is you're trying to balance the number of electrons gained and lost. Franz, is this point clear?
Yes, sir.
Okay, so you're focusing on this thing rather than balance. I mean, because otherwise balancing would be very easy. Like there are 2 nitrogens over here, you can have 2 nitrogens on that side. But the number of electrons gained and lost would not become equal in that way. And the rest is so the rest is you just have to balance the rest of the atoms the old-fashioned way. So it's going to be how many oxygens? That's 6 plus 5, that's 11. There are 10 oxygens already over here, so that's 1, that's 11. And so and the only thing you're left with are 2 hydrogens on this side. So there should be 2 hydrogens over here as well. So that's it. Now what we're going to try and do is that we're going to try, just one second, let me open the worksheet. We had a so just a second, let me open the worksheet, and we're going to jump to moles questions again. So now these are going to be difficult moles questions, the ones that involve redox reactions. So these ones over here. Okay, so moles and redox reactions and moles. So let me just reopen this. I said redox reactions and moles. Now, listen to this very, very carefully. These are going to be tough questions because it involves balancing the number of electrons gained and lost. They have to be made equal. So over here, there's a question, and it says that in an experiment, there's a solution of a metallic salt that reacts exactly with sodium sulfide. So a metallic salt, let's call that M. I don't know what that is. And it's reacting with sodium sulfide, which is Na2SO3. Now he's saying that the half equation for oxidation of sulfide is shown below. So this is the oxidation equation. This is where electrons are being lost. So, I mean, you're given an equation and electrons are being lost. So who's going to be gaining? Sulfide is the one that's losing the electrons. So who's the one that's gaining those electrons? It must be the metal in the salt. That is the one that would be gaining the electrons. So this is where you can see the electrons being lost, right? I mean, they've divided the equation into 2. I mean, that's the only thing that that they've done. It's something similar to this. Like you can divide the equation into 2 equations. Like this is the one that's gaining electrons and this is the one that's losing electrons. So this is exactly what they did. They have an half equation for oxidation. Sulfide is the one that's losing electrons. So electrons are being lost. So the metal in the salt is the one that's gaining those electrons, right? So he's saying that if the original oxidation number of the metal in the salt is plus 3, so they're saying that the metal in the salt is plus 3. And they're saying what would be the new oxidation number of the metal. Now the problem over here is that they've shown you half of the equation. They've shown you that sulfide is the one that's losing electrons, right? So you know that electrons are being lost. But they didn't give you an equation for electrons being gained. So you don't have an equation for reduction. So you don't know how many electrons exactly are being gained. So this is unknown. I mean, they've told us that M plus 3 is the original charge of the salt, of the metal in the salt. So electrons are being produced and electrons would be gained by the metal in the salt, but you have no idea how many electrons would be gained. And if you don't know how many electrons would be gained, you don't know what the charge on the salt or the metal in the salt is going to be. So the whole question is about what would be the new oxidation state? What would be this new charge? So what you're going to do is, we know that the electrons that are lost are equal to the number of electrons that are gained. I mean, this is what we were doing so far. This is why we were doing all these equations, that we were trying to make the number of electrons gained and lost equal. So in any reaction, the electrons that are produced and the electrons that are being gained, they must be equal. So we're going to try and figure out how many electrons are actually lost by sulfide. So they gave us the equation, they gave us the moles of this sulfide. So the moles of sulfide are given as 25 cm cube. The volume is given and the concentration is also provided. It's given as 0.1 mole per dm cube. So how do you find the moles of sulfide? You can just do N is equal to C into V. The concentration is provided and the volume is provided. So can anyone do the calculation? Tell me what moles of sulfide do you have? How many moles are we getting for sulfide? 25 into 0.1 divided by 1000, because the cm cube should be in dm cube. Mariam, have you tried this? Kausa?
0.0025.
So this one is coming out to be 0.0025 moles. So we know the moles of sulfide, right? And what does the equation tell you? It tells you that one sulfide produces how many electrons? It produces 2 electrons. So if you've got 0.0025 moles of sulfide, the number of electrons that are going to be produced are going to be double that. So if you double that, I think it would be 0.005 moles, right? So these are the electrons that are being lost by sulfide. Is this clear so far? Alicia, is this clear? Mariam, Aisha, is this clear?
Yes, sir.
So they gave us the moles of sulfide, and we figured out that these are the electrons that are being lost. And I told you that the number of electrons that are being lost and the number of electrons that are being gained, they must be equal. So how many electrons are being lost? 0.005 moles. So how many electrons should be gained? It's going to be exactly the same. It should be 0.005 moles. So I figured out the number of electrons that should be gained, because these two must be equal. Electrons lost, electrons gained, they must be equal. So what about the salt? They gave us the moles of the salt as well. That the volume and concentration of the salt are given. So how many moles do you have? You can do volume into concentration divided by 1000. So the moles of salt that you're going to get are, I think they're going to be 0.005 as well. Can you even check?
Yes.
So basically, at the end of the day, you had sulfite. It produced these many electrons, and the number of electrons that are lost, they are the ones that would be gained by the other thing, right? So the metal in the salt would be gaining these electrons. So we figured out that the number of electrons that should be gained would be 0.005 moles. And the metal in the salt is also 0.005 moles. So what's the ratio of, what's the whole number ratio? Like 1m would gain how many electrons?
1.
1. It's so they're basically reacting in 1:1. So that means one metal ion would gain exactly 1 electron. So what's the final charge on the metal? It's going to be
+2.
it's going to be +2, and that's your answer. So is this question clear?
Yes.
Anna, is this clear? Alicia, Aisha, Mariam?
Yes.
Yes.
Acha, so just remember this one was a tricky question. The other ones are also similar to this. So when you have a redox question, the number of electrons that are being lost and the number of electrons that are being gained, they have to be equal. There's a very similar question like this. There's another one actually. Let's do this one. Now this one is kind of an exact copy of that question, but you have different things now. So if you try to do this one, they're saying that, and you have to first interpret the question. So they're saying that there's a sample of Tl plus 1, NO3 minus 1, and it's reacting with NH4VO3. So something is happening. Tl plus 1, right? NO3 minus 1, and it's reacting with NH4VO3. So two things. So it's reacting with NH4VO3. And what is getting produced? He's saying the TL gets oxidized to TL3 plus. So we know that one of the products. It's turning into TL3 plus. And he's saying that vanadium is the only element that's reduced. And he's saying what is the oxidation number of the vanadium in the reduced form. So vanadium is the element that is reduced, and we need to find out what happens to it, right? So I'm going to split the reaction into two. I'm going to split it into two things: oxidation and reduction. So one thing is they've told us that Tl plus NO3 minus 1 gets oxidized to Tl3 plus. So that's your oxidation happening. Tl plus 1 changing into. So I'm just going to write that. So I've got Tl plus 1 changing into TL3 plus. Okay, they've already told us. Tl plus 1 changes into Tl3 plus. How many electrons would be produced? There are going to be 2 electrons that would be produced. Can I find out the moles of Tl plus 1, NO3 minus 1? I can. It's because the sample is given. It's 10 cm cube of 0.3 mole per dm cube. So can anyone calculate how many moles of Tl plus 1 do I have? What's 10 into 30 divided by 1000?
Zero 0.003.
So you're getting 0.00003 moles. So how many electrons are going to be produced by these? I mean, this is Tl plus 1, NO3 minus 1. So this is Tl plus 1, same moles. So 0.003 moles would produce, it's 1:2. So the amount of moles of electrons that would be produced would be 0.006 moles. So these are the electrons that are being lost. Now the number of electrons that would be gained is going to be exactly the same. So who's gaining electrons? So they're saying that NH4VO3 and vanadium is the only element reduced. So what's the oxidation state of NH4VO3? I mean, he's talking about vanadium. Vanadium is the only element reduced. So I need to know what the charge of vanadium over here is. Now NH4 is +1, so VO3 is -1. So I'm going to do this over here in the corner. I mean, VO3 is -1. So what's the charge on vanadium initially? If you try and solve this, it's going to be x and minus 2 times 3, and it's going to be equal to minus 1. So x comes out to be plus 5. So originally this v is actually plus 5, right? So the v over here is plus 5. Is this clear as well? To give you found the
Yeah.
oxidation. Now he's saying that vanadium is the only element reduced. So vanadium, which is plus 5, is the only element that's gaining those electrons that were, and I don't know how many electrons it's gaining, but the electrons that were produced in the previous reaction. So we need to find what happens to vanadium after that. I mean, that's the question mark, because we don't know right now how many electrons are gained. So we know that 0.006 moles of electrons were lost. So over here, 0.006, the same amount of electrons are going to be gained by vanadium. But they have no other place to go. So these are the same moles of electrons that would be gained by vanadium. How much vanadium do you have? They've given us the volume and concentration as well. So it's 20 to 0.1 divided by 1000. So the moles of vanadium would be 0.002 moles, right? So they've given us the volume and concentration of NH4VO3. So it comes out to be 0.002. So can you even tell me what's the whole number ratio now? I mean, because in the reaction we figured out that 0.002 moles of vanadium plus 5 are going to gain 0.006 moles of electrons. So what's the whole number ratio? It's 1
1 to 3.
So it's 1 to 3. So that means V plus 5 would be gaining 3 electrons. So the final charge on V would be plus 2. And this would come out to be 1:3. It's going to be 0.002 up, gaining 0.006 moles of electrons. So 1 would be gaining 3. And the final answer would be plus 2. Is this clear?
Yes.
Yeah.
Yes, sir.
Okay. I said these two were very tough questions. They were slightly more difficult compared to the normal questions that you get. So something similar, slightly easier questions. I mean, let's try and do this one. Let me just get rid of this. So let's try. It's now all of them are pretty much the same. The number of electrons lost and gained, they've got to be equal. So for example, this question, they're saying that they've pretty much given every information about this. They're saying that MnO4 minus 1 changes to Mn2 plus. So MnO4 minus 1 in the reaction changes to Mn2 plus. So this is given. And the Sn2 plus, they change into Sn4 plus. So in the reaction, Sn2 plus changes into Sn4 plus. Now it's not a balanced reaction because we don't know what the other things are. So I mean, this is the only information that's provided. MnO4 changes to Mn2 plus, and Sn2 plus are oxidized to Sn4 plus. So we can simply balance the number of electrons lost and gained. First thing is, what is the charge on Mn over here? They're 4 oxygens, so you can calculate the charge. And this would come out to be equal to, I think, plus 7. Like you can do this, it's x. This is minus 2 times 4. And together they are equal to minus 1. So solve this and it comes out to be plus 7. So that's plus 7. I said then it goes to plus 2. So that means it's going from plus 7 to plus 2. That means it's gaining how many electrons? 5 electrons, right? Like one of the Mns is gaining 5 electrons. Sn is going, on the other hand, from 2 plus to 4 plus. That means it lost 2 electrons. So how do I make the number of electrons gained and lost equal? I need to multiply this by 5. So there should be 5 Sns, and I need to multiply Mn by 2. So there should be 2 Mns. So now I know the ratio of Sn and Mn. It's 5:2. They're reacting in 5:2, even though it's not a fully balanced equation because I don't know what the other reactants are. I don't know what happened to oxygen. So there's lots of things missing in the equation, but at least the number of electrons gained and lost are equal, and I know that this must be the ratio in which SN and MnO4 would be reacting. So is this clear?
Yes.
Yes.
Okay, so we figured out the equation, like partially. Now he's saying that now the rest of the question is about simple moles. Once you have the equation, you have a redox equation, so you can just try and you know the ratio, you know the stoichiometry now. You can simply go and solve. So they're saying that there's 9.5 grams of SnCl2 and the MR is also given. So mass divided by MR, so it's going to be 9.5 divided by 190. So SnCl2 is actually Sn2 plus. Because I told you the equation, all the other elements are missing. So, there was Cl with Sn, so that's missing as well. So, can somebody find the moles of SnCl2, mass divided by MR?
0.05.
So you're getting 0.05. So that's the moles of Sn2 plus. Like SnCl2 has one Sn, so if you have 0.005 moles, there would be 0.005 moles of Sn2 plus, or 0.05 in this case. I said now, he's saying how many moles of Mn2 plus ions are formed. So you just use ratio, it's 5:2. So according to this ratio, it's going to be 0.02 moles. It's 5:2, so it's going to be B. Okay, is this clear?
Yes.
Yes, sir. Yes.
And so now, let's do some. We just have 4 minutes. I'll just show you some theory questions where. Just a second. Let's try and do this one. So, for example, we have this question. Not this one. Probably this one. So let's try and do this. Now we'll figure out the moles question later on. Now the first thing is he's saying use half equation to write an equation. So unless you don't know what the equation is, a redox equation always has gain of electrons. So this is the part where they are gaining electrons. This is the part where they're losing electrons, right? So write them in one equation. It's going to be, the first thing is the number of electrons gained and lost, they must be equal. So how many electrons are gained? That's 6. How many electrons are lost? That's only 1. So I need to multiply this by 6. And then I can simply sum up the reactants and the product. So there's Cr2O7. You write your reactants on one side and your products on the other side, and you just combine the two equations. You have already, the first thing is you have to make the number of electrons gained and lost equal, which we have already done. So the reaction is Cr2O7, 2 minus, that's one of the reactants, 14H plus 1, that's another reactant. There's 6Fe2 plus, that's a reactant. And the product is 2Cr3 plus and 7H2Os, and there's 6Fe3 plus. So you combine the two equations, combine the reactants of the two equations and the products of the two equations, and you get the overall equation. But for that, you have to balance the number of electrons that are gained and lost, and you have to make them equal. Is this clear?
Yes, sir.
I said, and remember, if you don't, because if you got the ratio wrong, then the whole moles question and a lot of the parts of the moles question you would not be able to solve. So similarly, there would be, this one is all about balancing. I'll just quickly do this one. Mn is +7 over here. You can find the oxidation state. Fe is +2. Mn is already +2, so that's all of this is given. Fe is +3. So Mn goes from +7 to +2. So that means a gain of 5 electrons. Fe, on the other hand, goes from +2 to +3. So that's a loss of just 1 electron. So to make the number of electrons gained and lost equal, I need to multiply this one with 5. So there should be 5 Fe's in the reaction. And there should be one Mn. So that's going to be 1. And you can balance the other things. There are 4 oxygens, so there's 4 oxygen, there would be 8H plus 1. So again, the whole moles question depends on this balancing. Although it's 1 mark, but everything would depend on this balancing. So you get plenty of big questions, something similar happening over here as well. TK, this one is also about, you need to balance these equations and then figure out what the product is. So, is this clear?
Yes.
Yes.
So let's, we're going to continue with moles tomorrow as well, but we're not going to do redox now. Okay then. Take care, everyone.
Allah Hafiz.
Thank you.
Bye bye.